So number 11, the key to this guy. So there were two basic things you got to do with every problem when you start off. One of them was to make sure you draw tangent lines being perpendicular to radii. What was the other? Draw all the radii. Or radiuses. I'm not a stickler either way. So that means I need to draw that line in. There we go. There's that moment of clarity. How long is that? 40. So for these problems where we're dealing with a chord, you look for right triangles that you can solve. So that's 12 there, that's 40 there, that's x there, there's the right angle from here. 40? Okay, the radius is 12 plus 28. And that radius is the same all the way around the circle. So that's 40 there, that's 40 there. They're all 40. And so now I can go ahead and use the Pythagorean theorem to find this length along here, x. The only thing you want to remember is that using the Pythagorean theorem to get x doesn't actually give you the answer. If I use the Pythagorean theorem, so x squared plus 12 squared is equal to 40 squared, what I'm going to end up with is x is equal to 38.15. I'm not going to get the full chord I'm looking for. Exactly, because the rule is if it's perpendicular to the chord, it bisects it. So I take this and multiply it by 2. That's why I get my 76.3. But the big new idea, the trick to remember with these, is I need to draw that radius of 40 units in. And it's the same thing I got to do with 12. With 12, I need to draw this radius here in of 4.7. Because it's 4 to get down to the perpendicular point, and another 0.7 to go to the edge. So that's 4.7, that's 4.7. And so the right triangle I'm working with over here, so there's a right angle there. This is 4.7 here. This is 4 here. Call that y. And that's the right triangle I'm working with. Which would be y squared plus 4 squared is 4.7 squared. But again, it gets back to that, look for places to draw that radius in to help you get through it.